Hello everyone, I'm still building NervForge, a browser-based procedural tree generator. So this will be fast-paced, technical, and with no fluff. Let's go. So what you see here is the same brush configuration before and after the different fixes and optimization. The first problem I had was that every root branch was spawning from the exact same point. So the fix for that was to introduce support for the spawn area. I added two parameters. The first one is area type itself, and then you can also specify the size of this area. So we have a simple drop down and a simple slider. And the implementation itself is dead simple. And now, instead of having a single point to spawn all the branches, we can really put all the branches apart like this. The second issue I had to fix was more technical and low level, but yeah, when you build the grid, then the problem is sometimes you need to figure out what is the size of a given text. So this was not good because it means that you have to delay a lot of the construction system for the widget until there is a screen assigned to that widget. The solution that I found for this is rather simple actually. So instead of storing the font information, so registering all the fonts, textures into the canvas, we are now just storing this information directly in the SceneManager. So now when building the widgets, we can just request the singleton that we have for the SceneManager, and from there get the font data that we use to figure out what is the size of the different text. The next issue was again a bit laudable, but we have a quick bug fix here. I was actually trying to add a layout row here in the parent layout, and at first this was simply not working. So in the end this turned out to be a two-line fix. So we just ensure now that we're always going to try to find the parent widget whenever we assign a parent to any layout. So the next problem was the most important one here, and it was about the self-repulsion between the branches on the level 1. For level 1 branches, you actually don't have any repulsion data at first. Here is how we're doing the processing. Level 4 will use repulsion from the first 3 levels. But the level 1 here is not using any repulsion data at all. So to fix this, I decided to try to inject all the sections for all the branches just dynamically when we are generating them from all the different threads. And this is the kind of result that I got. It was exactly what I wanted to get. But there is a problem, because the time that it's taking now to generate a tree went from something like 100 milliseconds to more than 350 milliseconds. So the final solution that I came up with was to use a different strategy depending on what is the current level of the branches that you're considering. For level 0 and level 1, for instance, you're going to insert each section dynamically when they are generated. And here we're going to figure out if the branch that we're considering is of a higher level, and in this case we're going to insert all the section into the spatial grid, but here we don't need to be safe because this is executed on a single thread. And with this deferred level threshold mechanism, I could get down to something like 130 milliseconds for the tree generation, which is starting to be acceptable now. But then I got another idea on how to improve further on the spatial grid usage. What we can do is, when we are constructing the spatial grid, so whenever we are adding a new section into a cell, we can use that to update some kind of mean value of the position of the point, and then you only get a single location per cell. So that's going to reduce significantly the number of physical interactions that you need to have with another foreign section. So instead of storing different point location in each cell, now the cell data that I have is only containing a center value and a weight for that center, and we can add points progressively. And the result with that is that now we are about 37% faster than what we have with the deferred level threshold only. So a good speed boost with minimal quality lost. I'm taking this. Finally, there are two additional quality of life features that I added. The first one is a global scale with a uniform toggle. The second thing that I have added is I have updated the wedge curve mechanism to also take the current length of the leaf into account. And I've also added this curve power to control a bit more precisely the shape of the curve that you want to have. So if you increase the wedge curve value now, you can get very strange result for some cases like this one. But well, I guess it might still be useful in some cases for some specific plants. And this is it guys for this quick update. I hope you like this recording, and if you have any question, as usual, just let me know in the comments. And for my part, I keep working on this tool and I'll let you know whenever I get something new. So thanks for watching and see you next time. Bye bye.